Okay, hello. This is the second time I'm recording this. I'm Derek Townsend. I'm in your IT 354 354 class, and this is my 1 second. We'll come back to that. And yes, this is my first video on the numbers and unary operators and all that. So pretty much I'm just gonna go through here and like kind of explain my code and everything. So let's start off with numbers. So numbers are essentially the building blocks of all math and stuff. So essentially they are like so in other languages we would have like, and this would be an integer, this would be a floating point right here, and this would just probably be an integer again. But the thing about JavaScript that allows you to do scientific notation, which is I guess is useful. It allows you to save some room when you're writing your code, I guess. So let's run these. So the data type of these is always numbers, so that's just what they are. They're all stored the same. There's nothing different between any of these numbers. The problem becomes is when JavaScript only allows you to store a certain amount of numbers before it gets runs into some issues. And this is what happens when it runs out of, like, when you put a number either big too. So infinity and negative infinity are what happens when you have numbers too large or too small for JavaScript. So this right here is infinity would be like, this number would be so large that it essentially just get categorized as infinity. And infinity is infinity. You usually use it to pretty much evaluate something. Like if you want to see, like if you're starting to try and find the lowest number or largest number in a group, you start off with infinity. And then if it's larger than that, oh wait, if you're trying to find the smallest, so like basically you can use it to like try and logic your way through some issues. I've never used infinity or negative infinity before, but I'm sure they would be very useful in those situations. So if we run this, we get infinity, infinity, negative infinity, negative infinity. Yeah. So let's move on to not a number. Not a number is essentially what it sounds like. Not a number. It basically takes anything that isn't a number and it says yes, that's not a number. So if you try and do math or do like multiplication, well, you can get away with it, but that's used mostly just with strings and stuff. But like in this specific case, if you do not a number, it'll, like if you're trying to like multiply a function or something like that, it will probably give you an error like this is not a number, you cannot do this. But if you try and multiply a string, it'll return the string 3 times. I think there's a lot of weird things you can do with strings. But in this case, not a number, and then there's a function called is not a number, and essentially it returns true if it's not a number, and returns false if the what you're evaluating is a number. So we should get not a number, true, false, false when we run this, or false when we run this. As you can see, not a number, true, false, false, true, false. Why do I do that again? Strings. So we have strings are essentially a grouping of array of characters that have been joined together. So strings have 3 ways they can be written. They have double ticks, single ticks, and backticks. Backticks allow you to do string interpolation, which is where you can like insert variables or do math or do something quickly inside of a like per output. Or if you're trying to, it allows you basically structure your string and your variables without having to use pluses or is it concatenation? No, it doesn't matter. But yeah, it basically just lets you do that. So here, so when we print this, hello, it'll just print out hello, hello world. It'll print out hello world, and this will print out hello comma world. And it's just, these are all the same essentially. They'll be stored the same. There's nothing special about them. It's just like how you can use them. I personally prefer double ticks and back ticks. If I'm just using it for general usage, I'll do double ticks most of the time. And as you can see, hello, hello world, hello comma world. Exclamation point. Yeah. Next one. I'm sorry if I'm glitching through this or if I'm going through this too fast. I have filmed this just again recently, but half my screen was cropped off, and it's pretty much unsalvageable. Okay, now we have type of. Type of is essentially like lets you know what type whatever you put into it is, whatever you put into the function is. So type of 5 without quotation marks, without anything else, will return number. If you have type of like string 5, it will return string. If you have type of curly braces, it will return object, because that's what an object is. Actually, just curly braces with some information inside. The way it's structured, there's specific structuring, but I'm not going to get into that. So if we run this, it should return those. And you could use these to make sure that the input or output that you get is the data type that you want it to be. Make sure that you don't have, like, if you somehow do some addition with some addition with things you convert to strings, you don't want the output to become a string. You just want to make it, you basically use for verification. Make sure that you are getting what you say you are getting, what you think you are getting. And if we, so yeah, so as we see, when we ran this number string, or string object. Here. Now we're going to move on to plus, the unary plus operator. Is that what it's called? Yes, unary plus. So plus symbol is pretty much what you expect. It's like your basic arithmetic plus addition symbol. Whatever you add together will return the sum of. So 5 plus 5 equals 10. If you want to convert, like, so let's say you will have a string with a number in it, like we have here on line 30. It will convert that to a string integer format or number format, but it will not affect it. It will not do like negativity or anything like that. It won't affect it. It won't make it positive. It will just return what it is, but in number form. Also, with the plus symbol, you can like add numbers to strings, and it'll essentially make the string version of that. It's a bit weird. It worked differently. It worked differently a while ago, but like, and also you can add strings together. Well, I don't think it worked differently. It's just like, I don't think it worked the same. I would need to look more into it, but like, it was weird. Like, yeah, it was very weird for a while. So let's make the, like, in adding strings together, you can do worldwide, and let's update this right here, and let's run this. So this is print 10, 5, -5, 1 world, and then worldwide. I think you can do it on both sides. Like, I think it gets a bit weird when you try and do one like this, -1 here, just to show you that this is where not a number comes into effect right here. Just to swing that back around. But yeah, like if you're trying to subtract from a string or object or something like that, it will be like not a number. You can't do that. So let's move on to minus. Okay, so minus is same thing. It's used for subtraction. Subtraction will find the difference between the two numbers. 5 minus 5 is 0. And the thing is, when you have it interacting with strings that have numbers in it, like so string 5, if you minus that, it will return -5. It'll negate whatever the number is. I don't know if I mentioned that, but I am now. So if we have negative string, okay, string -5, it will return 5. Because if you're negating a negative, it will return positive, that number. So let's run that. So we have 0, -5, 5. Now let's move on to not. So not essentially takes whatever the Boolean value of it is, like so whatever the Boolean value is, and it reverses it. So Boolean values can either be true or false, and if you do not true, it will be false. If you do not false, it will be true. So when you print these, it will return true and false, or false and then true. So as you can see, false, true. Let's comment that back out. Now let's move on to double not. Now I don't know if this is actually called that, but not false is like the double not. I tend to say that this is the way you get the absolute Boolean value. Where if you want to, like, let's say you want to set like a variable, let's say let x equal 1, but you want 1 to actually equal the true or false. Because like, so in order to explain that better, there are truthy and falsy values in JavaScript and like other languages as well, but like specifically JavaScript right now. So the way truthy and falsy works is that, like, if you have these numbers in like if you evaluate them in a if else statement or if statement, let's do it here. We have 1, let's say 1. 1 is considered truthy. 1 and what else is it? 1 and pretty much everything but 0 is considered truthy in JavaScript. So if we do if 1, it will return here. It'll like actually it'll evaluate the true and allow it to print here. But if we do 0, it will do it won't print it at all because we haven't set up an else statement, and it will evaluate 0 to false. I think 0 is the only one in number, like in terms of numbers, that is false. Falsy. So that's what we go through here. So like when we go through here, when we go back here, we want, so true will turn true. So essentially this is saying not true, which would be like, so true. And if we do not false, it'll be false. So the two nots are canceling each other out essentially. But it, once again, as I said, if you want to get the absolute true value, not the number, or like if you out of a truthy or falsy value, you will do not. And here we have 1 not true, that not true, or not 0, exclamation point 0. It will be false. And same thing here for -1, -2. Let's actually test that real quick. So 2 should be also true as well. Let's test that. Yeah, so it's pretty much just 0 is the only one that will return falsy. Excuse me. Actually, I'm not sure. Let's see what 0.5 will do. True as well. So yeah, that should it's pretty much remain the same. Okay. So let's do comment that out. Excuse me. Increment and decrement. So we have let's see equal 5. And we have, okay, yeah, so increment and decrement basically allows you to increase or decrease the value by 1. So if we go through here, so we have let c equal 5. So we have c equal to 5 right here. And then we are incrementing c by 1 when we do 2 pluses back to back. And now the value will be 6. And then we do it again. Now we're doing decrement. We decrease the value by 1 again, and it'll return it back to 5. And it's most often used in for loops, where we see here that I plus, like as you go through here, let I equal 0, I is less than or equal to c, it'll console log I, it'll then like increment I. So basically just like allows you like on each loop, it'll increment the number by 1. But with something I didn't notice, that like, so here we can do plus plus both ways and it'll work fine. Plus plus like in front of it and it'll work fine. But if we do it behind it, it'll work fine. But if we do plus plus or minus minus in front of it, in the console log, it for some reason it doesn't affect it at all. With something just like something minor, but I just found it interesting. But like, so let's run this. So as you can see, we have 6, 5, and then it goes through the loop here. But yeah. So essentially, the reason what it's doing is also equivalent to like c is plus, or what is it? Plus equal to 1. Yeah, plus equal to 1. So doing this is essentially the same thing as saying c console log. Let's do it in between. It would be better to do it in between here. So c plus equal to 1 is essentially the same thing as this, and we can remove the plus plus and just print it, and it'll do the same thing 6, 5. But it's saving a little bit of time, and it's useful, and it looks cleaner in some ways. Well, it looks cleaner in some ways, yeah, and it's a bit nicer. But yeah, as you can see, that's pretty much incrementing and decrementing. You're just increasing and decreasing the value by 1, and setting the value equal to it as well. Okay, we have delete. Delete. So essentially, delete, the way it works is that it works the way, like, so we have an object here, and it allows you to remove an attribute and value from it. So what we want to, so here we start off with an object called enemy, and we have first name, last name, Michael, Alfred. This isn't a real person, by the way. This is just like a character I use for like pretty much everything, because John Doe got boring after a while. So we have first name. So enemy.first name, we print it off. It'll print off his first name because nothing has happened to it yet. But here we're going to delete the enemy.first name, and it will return true. That's the thing about delete. It will always return true, even if like if it returns that like if it If it does not, if it can't find it inside of the object when it's calling like enemy.firstName, again, assuming at the end, if it can't find it, if it returns undefined, then it counts it as true. And enemy.first, so we're deleting it, and it's like enemy.firstName.true equals true, and then we do console log again, it'll return undefined, and we console log it again, or like if we console log delete enemy.e, something that was never in the first place, it'll still return true because it's like, hey, this doesn't exist. I guess we deleted it then. So let's run it. So we have Michael, as I said, Michael, then true, then undefined because it's been deleted, and then enemy.yeet.true or enemy.yeet will return true because it technically deleted it because it's no longer there, but it was never there to begin with, to be fair. So yeah. So next one. Hoisting. So hoisting is kind of a bit of a older remnant of JavaScript, earlier JavaScript. So this comes from the var era. So hoisting essentially takes named functions and named functions and variables declared using var and essentially take them to the top of your declaration tops and declare all of your variables at once. And it has some issues where it would like essentially if you have variables with the same name, they'll run into errors even if you didn't have them. Even if like they were in different locations, it could run like essentially just led to more issues. So to show the example of this issue, so normally what you would expect is that like if you excuse me 1 second. So here in the console log statement, so we're gonna do one before, one before, one after. So in this first So in this first print right here, we're just gonna run the function normally, and everything runs fine. You get hello world. But what you would expect if I let the print run here instead, you would expect undefined because, or like you would expect an error, like an actual error, because it's like print hasn't been created yet. There's no way to reference it. But because of hoisting, oh wait, oops, that is a mistake on my part. Oops, not my that's not what I meant. I was looking more for where is it at? Huh. Okay, that was a mistake on my part. But specifically this section, that's more of an example for this section right here, and less of this one. But if we comment this out right here, and we run it, it'll return undefined because statement has been hoisted to the top and been defined, but it does not yet exist is the problem. So essentially the error we're expecting is essentially something along the lines of this. Reference error, like it does not, like statement is not defined, it doesn't know where it is, it hasn't been defined yet. But yeah. But as I said, this example of function, like the function afterwards, is a bit more for this section right here. So essentially to fix this problem of hoisting, JavaScript, like in ES6, I think it was, or something along those lines, introduced let and const. And with let and const, we introduced something called function expressions and other things in order to like help mitigate this issue. So we've changed the way the function is set up to a function expression where print const right here. So first of all, let's show off the thing I was trying to show off before so this should work fine right now. This should print out normally. So let's make sure it works first before we do anything else. So this is it running it normally. This should print hello world, and it does. But if we let this print run, oops, sorry. If we let this print run, it should throw an error now. Yes, reference error, because print is not defined yet. And this is because of const and also because of function expression. Because I'm actually curious, because I haven't tested this, so excuse me if it does not work the way I think. So let's take this code, print, var, print. Can you do this? I've never really played around with this sector, like right here. So let's do it again. If we do var, what will it give us? Okay, that will throw an error as well. Okay, so that's for var as well, but not specifically for that one. Okay. So okay, so where are we at? So we were like here. It throws a reference error as it should. And we have inside, the same thing happens inside for let. If we do this here, instead of returning undefined, which did I show up here? I did, I think I did. But yeah, if not, I'll show it again in a second. But yeah, so we have here print. Oop, nope, that I need to comment this out. So this is like the proper order now. So because print does exist here. And now it's going to do the same thing, reference error, because statement is not defined. Statement is defined here. So let's comment this out and uncomment this one out. Run it. And it'll return that proper. So return statement. And let me just make sure I go back and do this properly to make sure that it's undefined, because it's going to drive me crazy otherwise. So we have this console log statement. Okay, so if we comment this one out, this is the problem with hoisting, because it will raise it up and it'll allow print out undefined. Yeah, just want to confirm that. All right. Okay, so thank you for your time. This is pretty much my code. I've covered everything: hoisting, delete, decrement, increment. Yes, that's everything. Yep.